but not your touch laptop, because most touches rather not touches. Most touches have rechargeable battery. That's one of the plans. But some of those old touches that you put battery inside them, there's one that they call is the after NECO or the 4-1. Those kind of batteries are called the flagship. Now, for those of you in SS2, you've done electrolysis, right? Chemistry.
Yes, sir.
Okay. Now, the component is at the anode. At the anode, what happens? There is oxidation at the anode. So zinc is oxidized. So zinc will be oxidized to give me zinc, and it loses 2 electrons, right? That's oxidation at the anode because zinc is one of the components. Then carbon is the electrode because carbon does not react, so does not react with those components. So carbon will be used as the electrode. Now, what is a depolarizing agent? Now, the depolarizing agent is because of what occurs at the cathode. I think those necessary. You've done anode and cathode. Anodes or anions, sorry, anions and cations. So anions are negatively charged ions. So that means your anode is positive. You have to attract negatively charged ions. So at your cathode, what happens is that you have manganese dioxide, which will react with hydrogen, and it will give you what? It will give you, sorry, at the cathode, sorry, I'm already going to the answer already. At the cathode, you would have what's the name? Ammonium. So this is ammonium. And reduction takes place, which means these 2 electrons need to add. It will gain 2 electrons to give me ammonia plus hydrogen. Now there's an issue with hydrogen. If you don't remove the hydrogen, it's going to cause an issue because that's what is called polarization. Polarization simply means a situation whereby the hydrogen forms bubble. I get it. This hydrogen that is being formed at the cathode would form bubble because it is a positive electrode. It's going to act as an insulating layer, and it will reduce the current and the voltage. So if you don't remove the hydrogen, it's going to actually do what? Increase your internal resistance and then reduce the current output and reduce the voltage output. So even though the chemicals that you need are still there, because of the hydrogen there, it's going to form a bubble of gas. So what you do is that you add a depolarizing agent or a depolarizer that will remove the hydrogen. And that depolarizer is actually manganese dioxide, or you can call it manganese 4 oxide. And let's see the equation of how it removes this troublesome hydrogen, because hydrogen will keep causing bubbles there. So that's manganese dioxide. So I have manganese dioxide. So that's 2. Let me just write the balance equation. So I have 2MnO2 plus hydrogen. It will now give me, when I balance, it will give me Mn2O3 plus H2O. This is balance. Manganese is 2, it is 2. Oxygen is 4. 3 plus 1 is 4. Hydrogen is 2, it is 2. So good. So this hydrogen that was problematic, causing bubbles, is now being what? Oxidized to become water. And water is not problematic. So the answer is manganese oxide. Because if you put carbon, for example, carbon, like I said, does not react with all these constituents. So carbon will not react with A, B, that means C. Carbon rod to the same thing. Carbon rod is already there. It's the electron. Alright. Question 61 says, which of the following has dimensions that are equal to the rest? Which of the following has the same dimension? Okay, sorry, has a dimension different from the rest. So stress over strain. SS2, SS3, we've done elasticity. Alright, so let's look at each of them. Okay, true. SS1, you've done dimensions, right, in physics.
Yes, sir.
Okay, good. So you just want me to give you the form that so you'll be able to follow. All right.
That
So
was the answer D.
you say the answer what?
D.
Well, I'll check, but I think the answer is B. Let's just confirm. Now, stress is force per unit area. Are you getting me? Stress is force per unit area over strain. Strain does not have what? Strain does not have dimension. Strain does not have dimension. So I have force over area for the first one. So we have stress over strain. So for the first one, it's going to give me force is ml t raised to power of minus 2 over area is L squared. So it's going to give me ml raised to power of minus 1 t raised to the power of minus 2. So let's see stress times strain. Okay, wait. Oh, I think you said D. Okay, I think you are correct, but let's confirm. Let's confirm. So first of all, stress over strain is going to give me FL over AE because this is stress is force over area divided by strain is extension per unit length. So it will give me L will come up, FL over AE, which length over length, their own unit will cancel out. So it's going to give me F over A in terms of the dimension, which is ML to this power. So force per unit area, first of all. So let's look at B. B is stress times strain. Now, stress, like I said, is force per unit area times strain is extension per unit length. So since this one is L over L, they will cancel out in dimension. This will give me F over A, which is the same. Now pressure is force per unit area already. That's the definition of pressure. So it goes straight to force per unit area. So you're right. The answer is D, torque. Torque is the rotation, which is force times distance. To explain torque, a very good example is your Coke, your Coca-Cola bottle. To turn it, you have to hold it at this point and hold it at the other point, and then turn it or your cover, yes, the cover of your water bottle. Let me throw the water bottle. No lack of memory. So this is your water bottle. So to open it, you place your hand here. Let's say this is your hand, right? So you place your hand here and you start rolling. So that force you are applying, one is acting here, the other one is acting in this direction to cause the cup to open or close. It's called the torque, and it is force, the force you are applying the force times the perpendicular distance. So it is going to be force, which is times perpendicular distance. So it's force times distance, which is different. The rest gave me F over A, F over A, F over A. So the only one that is different is actually D, which is the torque. Good, so you are correct. Thank you. So 62. A capacitor described as a mica capacitor has dash. What does it mean to have a mica capacitor? Which of them do you think? Well, for it to have a okay, what do you think? What do you think first? What do you think is the answer? Okay, let me just jump into it. Now, a capacitor is a device used to store charge, and this is simple. So there's a substance placed in between, which is called the dielectric, so that these two um, these two plates, are you getting me? So that these two plates don't become polarized. That means they don't become charged and then react with each other. So that it's like kind of like an insulation, so that this capacitor can store more charge. So if it's called a mica calculator, then that means the dielectric material which is placed in between the two plates to prevent them from conducting electricity to each other instead enable charges to be stored is made up of mica. So it means what which of them means that what the dielectric is of mica. That's why it's called the mica capacitor. Question 63 says, in which of the following devices is thermal expansion considered a disadvantage? Now, thermal expansion is expansion due to heat. Like when you're hitting your port, it expands, contract when it moves. So your fire alarm, that fire is being detected as your fire alarm. When the fire is coming up because it is heat, the metal in that fire alarm will expand, and once it expands to a particular degree to trigger off an alarm that there is heat here, intense heat. So that's actually not a disadvantage. Thermostat is using, though we don't usually use it in Nigeria because in Nigeria we use AC. But in Europe, they have a thermostat that regulates the building, I mean the temperature of a building. So when the temperature is too high to a particular point, it hits the metal will expand to a particular point and trigger the temperature of the room to be reset. So that's not actually a disadvantage. Bimetallic thermometer, from the name thermometer, it is used to record temperature. So that's why when the metal inside expands, you know that okay, the temperature is increasing. When it contracts, you know that the temperature is reducing. So that's also not a disadvantage. The only disadvantage here is the balance of the watch. That's why when the watch expands, what happens? The watch will stop. Going to reduce the accuracy. The watch will start having accuracy, that kind of watch. Whereby balance super has its good linear surface. What don't happen is that that sphere is going to be the focal length of the mirror that will be formed. I get it. So the radius of curvature. So now, I solved the question on that earlier, where I said that the focal length is radius of curvature over 2. So since the diameter of the sphere is 20, that means the radius of the curvature of the mirror will be 20, then over 2. So the focal length will be 10. So what will be formed is a concave mirror of focal length 10 centimeters. You get that part?
Please explain it again.
All right. So here's what I said. Now they said the inner metasphere, right, of diameter 20. So that's the hollow metasphere of diameter 20. I get it. So it is now polished. So for a mirror, like the difference between mirror and glass, they are both the same thing. But at the back of the mirror, it is polished. Like usually it is green. You bring the mirror, you see green or green polishing at the back. So that light will not pass through, instead to reflect back on the image. So they now polish in. I get it. So that means the light is coming here. This other side that is polished will reflect it back as a mirror. That becomes a mirror. So we're now told that the diameter of this sphere, that is diameter, is 20 centimeters. That means it's going to be the radius of the curvature. I get it, of this mirror. It's going to be the radius of the curvature of this entire mirror. And so the focal length for a concave mirror is given by R over 2. The focal length, focus at the center point. That's what the mirror is talking about. You focus the image at the center point. So it's going to be, what is the radius of curvature? 20 divided by 2 is going to be 10 centimeters. So it's going to give you a concave mirror, which is called mirror, of focal length 10 centimeters. You get it? Do you get it?
Yes, sir.
All right. So, okay. 65 said, which of the following statements about a projectile is not correct? First one says a projectile is a two-dimensional motion. Of course, it's a two-dimensional motion. Because when you launch a projectile, like for example, when you shoot, when you throw a bomb, like for let's say there's a jet fighter, it throws a bomb at a particular target, fires it at a particular target. It is moving in the y-axis, that it's falling from the height down, and it's also covering some distance in the x-axis. So it's two dimension, y and x. That's correct. B says a projectile is an object that is launched into air and allowed to move freely. Like I said, yes. All you need to do is to guide it. That's why they use angles. At what angle will you fire the bomb to reach this target? So yes, that's a projectile. C says The range of a projectile is independent of the acceleration due to what? To gravity. And this says the time of flight is dependent on the acceleration due to gravity. Now, what answer is incorrect? The answer is C, because the range is not independent of the acceleration due to gravity. The range is not independent. Gravity still falls on, because definitely in the definition of a projectile, number 2 says it is an object that is launched into air and falls freely due to gravity. So it is being guided by gravity. So to say that the range is independent of acceleration due to gravity is a wrong statement. So the answer is actually C. Do we get that?
Yes, sir.
So the next one, question 66, says atmospheric pressure decreases with increase in altitude. Why? Because, well, basically the truth is, the higher you go, the lower your air is, right? And pressure is force per unit area. So force per unit area. So if you don't have much molecules of air, what happens is that what there will not be enough pressure to be exerted by the atmosphere. So let's look at the answer that correlates to what I say. So the answer is D. Yes. The interaction between air molecules decreases because there's less quantity of air. And as I see, when you see people that are climbing high mountains like Mount Everest, they will go with oxygen mask, because the higher you go, the lower the amount of air that is available for you to breathe in. So the answer is actually D. So that's why the pressure increases. Decreases, sorry. Now question 67 says, what is the main difference between X-ray and gamma ray? What is the main difference between X-ray and gamma ray? What do you think is the answer? What is the main difference between X-ray and gamma ray?
The mode of propagation.
The mode of propagation, correct. Because both of them have ionization ability. Both of them have been sorry. Are you seeing it now?
Yes.
All right. So 67. Now, both of them have ionization radiation, right? So gamma rays are more penetrating. What? I didn't get what you said, please. Hello, can you hear me? I didn't get what you said. Okay. So just proceed. But if you are still on the call, please let me know. Let me know. So the difference between them is in their mode of production. Yes. The difference between them is their mode of production. Alright, because both of them have ionization ability, both of them are propagated in the same way, they move in the same way, and both of them are also being absorbed. So the answer, the correct answer for their difference is in the what? Their mode of what? Of production. So, question 68. What is a phenomenon used to explain um, rainbow in the sky? What is rainbow? Rainbow is basically consisting of 7 colors. I remember people who spread the rumor that if you get to the end of the rainbow, you're going to find honey. And if you watch Winnie the Pooh, that was one of his quests. Every time Winnie is always looking for a way to get to the end of the rainbow so he gets his honey. Anyway, so basically what happens is that light is being separated into your 7 primary colors, your ROIC B, right? ROIC B. So your 7 colors. So since your rainbow has all 7 colors, that's your rainbow in the sky. You have the 7 colors. So what is called dispersion. That means light is being dispersed into different constituents. So it's called dispersion. Do you understand?
Yes, sir.
All right.
Yes, sir.
Okay. Yes, sir. Thank you. 59 says which of the following modes is the most economical method? Which one is alternating current, right? Because direct current will be lost, it's going to be depleted over time. So anyone that contains direct current will not be out. Option C and D are out. Because you have to use alternating current because it is varied. At least there will be a big value when you to get some. So now the question is now, is it at low voltage or is it at high current they are going to transmit? What is it going to be?
Low voltage and high voltage.
Is what?
Low voltage and high current. Low voltage and high current.
All right, yes. So it must be an alternating current at what? At low voltage and what? And high current. All right. Correct. Now question 69. What's the answer to question? Okay, no, 70. Not 69. Sorry.
The answer is A.
Okay. Question 70. We are picking A. What do we have?
Low, medium, high.
Are we sure?
Yes, sir.
All right. So we're looking at what? Alpha particle, gamma particle, and what? And the beta particle. So what this should get? This is ionization power. So what? Sorry. What option did we pick?
A.
A. All right.
Yes, sir.
A says low. Wait, are you seeing the sequence? You have alpha, beta, and gamma.
So I know it's alpha, gamma, beta.
Okay, sorry. Alpha, gamma, and beta. Yes, you're correct. I mixed it up. Alpha, beta. So, let's see. Which of them has the highest ionization power? Which of them? Now remember, I'm not talking of penetrative power. We're talking of
I'm not seeing your screen. Sir, please, I'm not seeing your screen.
Wait, just give it time. I think it's your network. Listen it. Are you seeing it? Have you seen it?
Yes, sir.
All right. So the one with the least ionization power is actually what? Is actually gamma. Gamma radiation has the least ionization power. So gamma is at the end. So I have alpha, beta, and then gamma. So gamma is at the end. So gamma is the low. All right. Then the next ionization power is beta, which is medium. So the answer is coming up low to medium. Says beta. Oh, once again, sorry, I'm mixing it up. And I'm already using alpha, beta, gamma. So the question actually said alpha, gamma, and then beta. All right. So I'm the one making the mistake. So the least, are you following me? The least ionization among them is what? Is gamma radiation. So gamma has the lowest one, while alpha has the highest one, and beta has the moderate or the medium one. Moderate or medium. So which one is the answer? High, low, and medium. So the answer to question 70 is actually D. High, low, and medium. Do you understand?
Sir, please, why does gamma have this ionization energy?
Okay, good. Now, the reason why gamma has the least ionization energy is that number one, it is an electromagnetic wave with no mass and no charge. Are you getting me? So it has no mass, no charge. So that means it rarely collides with an atom. Are you getting me? So it cannot really ionize due to its lack of mass. But you know, alpha is helium atom, so it has mass 4 2 helium. So it has a heavy mass to be able to collide with metals. Not metals, matter, and so cause a what high ionization. I hope that answers your question.
Yes, sir.
All right. So the answer is high, low, and medium. So question 71. Let's do 71. It says four pieces of wire, E, F, G, and H. So what are their lengths? E, F, G. Time is coming up. So this one is 1 meter long. Okay, each of them have the same length, but their diameter. This one is 1 millimeter diameter. This one is 2 millimeter diameter, 6 and 10. Which wire will have the higher? Use the formula for resistance. Resistance is resistive length over A. So since the length is constant, so what does that mean? That means the resistance is what? Inversely proportional to the what? To the area, of which the area, since it is what shape is a wire? I think if I'm to guess, I'll say if I'm to speak, I'll say it's a cylindrical shape, right? Your wire is cylindrical.
Yes, sir.
So it's going to be an inverse of the what? Of the area of that what? Of that cylindrical wire. So that means your resistance is inversely proportional to the area which contains the resistance. So that the smaller the resistance, or the smaller the area which contains the diameter, right? Like this way.
So like you said, the resistance is inversely proportional to what?
Is inversely proportional to the area. Are you getting it?
Okay, sir.
Alright. So the resistance is inversely proportional to the area, which of course is a function of the diameter. So that means the smaller the diameter, or which corresponds to the area, the higher the resistance. So which of them has the smallest diameter? It is E. So the highest resistance will be wire A, which is
Yes, sir.
all right. Now, question is a straightforward question. What's the answer? What's the answer? 72. Maximum amplitude. Very good. We didn't pick anything for 69. Yes, amplitude. Wait, we didn't answer question 69.
So the answer is B.
Okay.
The answer is B.
All right. I was saying it normal. All right. So for where are we? For 72. Now, for a wave, I told us what a wave is like, up and down, up and down. So the maximum point is called the amplitude. So the answer is actually B, amplitude. Question 73 says a non-conducting vessel. Time is up. A non-conducting vessel. Let's just see where we can stop. A non-conducting vessel contains 70 grams of a liquid at 25 degrees Celsius and another 70 grams of the same liquid. Well, basically, let me just give you a short thing to do. Now, since both of them are the same substance, they have the same specific heat. So if you do mass times C change in theta is equal to MC change in theta. Basically, they will come to, since it's the same substance, are you getting me? They will come to an equilibrium position, because just like if you drop hot water into cold water, it will become warm. That means both your hot water and your cold water, they will not be hot, they will not be cold. They will come to a midpoint because both of them are the same substance. So basically, once you see a question like this, what you just do is very simple. Just get the midpoint of the temperature. That's just the short method to just do it. So 25 plus,
you get the what? Boiling point.
The midpoint of the temperature. Just like a very practical example is you have hot water, you have cold water, right? If you mix the two, that mixture will not be cold. That mixture will not be hot. Instead, it can be, let's say, warm, right? So what you just since it's the same substance, the same mass again of the same substance, that means their specific heat capacity is the same. So what you just do, you just find the where they will meet. So it's going to be the midpoint of their temperature. So 25 plus 35, what would that give me? 70. Am I correct?
Yes, sir.
Okay. So I sure no, it's 60 now. 60, not 70. 35 plus 25 is 60. Then divide by 2. So the equilibrium temperature will be 30 degrees Celsius. You understand what I just did? So instead of wasting our time solving, just use that knowledge of common sense of what happens when you mix same substance of different temperature. You get it?
Yes, sir.
All right. So 74. Time is up. 74.
Yes, sir.
A galvanometer with full scale deflection. Well, the formula for a shunt. What's a shunt? We discussed it in one of the questions. What's a shunt? Who remembers? What do we use a shunt to do? Come on now, someone should remember. What's a shunt? Don't you remember? No, I didn't call the name. But basically there was a question we said that they want to convert an ammeter to a milliammeter. Do we remember? I said you connect something in of low a resistance of low value in parallel. That resistor you are connecting is called a shunt. It is used to do what? To convert your what? Your ammeter into a what? Into a milliammeter. Okay. So well, for this one, it's just straightforward. For a shunt, I got him. What did they say we should find? They said calculate the shunt you needed to convert it to measure 2 amperes. So it's going to be resistance of shunt times current minus current in galvanometer is equal to current in galvanometer times resistance of galvanometer. Now, why are you subtracting the current in the galvanometer? Because you need to get what the amount of what of current that will remain that will enter into the shunt. Basically, what I just do is just V is equal to IR. Hope you know V is equal to IR. So for the shunt, the voltage is the current is going to pass through the galvanometer first. So you have the remainder. That means after you subtract the one in the galvanometer times the resistance of the shunt is equal to same thing applies for the galvanometer. Current of the galvanometer, because the galvanometer will take off first, times the resistance of the galvanometer. So now to get ROS, it is going to be IG times ROG. No. IG not. So resistance of the shunt is going to be IG times ROG all over I minus IG. So let's go. So what's the current in the galvanometer? It is what 10 milliamperes. But don't make that mistake. Milliamperes is actually not the standard unit. So you convert milliampere, which is going to be 10 over 100. Where are you? This is 10 over 100. Sorry, 1,000, sorry. Milli, like from your millennium is 1,000, not 100. 20 that is 100. So 0 times 0. So it will give you 0.01. Exactly, thank you. So it's going to give you 0.01 times. What is the resistance of the galvanometer? 5 ohms, right? Right?
Yes,
According
sir.
to the question, yeah. So it's going to now be the total current to be 2, which is the total current you want to measure, minus what is the current in the galvanometer that we just got now? Is what? 0.01. So the resistance of the shunt is going to be equal to 0.05 over, it should give you 1.99. I hope I'm correct. Yes, it should. So help me divide that. divided by
0.025.
0.0. Are you sure? Okay. Sorry, I made mistake. Yes, 0.025, which is approximately okay, which is option A. So it's approximately option A. All right. So 75 says installing magnets, keepers. What are the keepers used for? Have you done magnetic field?
Yes, sir.
All right. So what do we use keepers to do? So your magnet has poles, not as south poles. So what do you use the keepers to do? Is it to cancel the magnetism of the earth? Definitely not. Is it to reduce demagnetization? Or is it to protect from electric fields and or to increase strength? What do you think? Okay, logically, what do you think? B, right? Yeah, the answer is actually B, because you don't want your magnet to lose its magnetic ability, because hence it becomes worthless. That's the use of a magnet. It is magnetic field that makes it valuable. So what you do is that you place what? Your keepers. Your keepers are made up of soft iron bars, so that they are placed between the poles of a magnet, so that magnetic flux is not being leaked and such, making your magnet to lose its magnetic ability. So the answer is actually B. What protects you from the effect of the Earth's magnetism is called magnetic shielding. Magnetic shielding, not keepers. All right. So now, which of the following factors affects the speed of sound? Okay, they said does not. Does not. Sorry, my bad. Does not.
Loudness.
Temperature. Exactly. Loudness, right? Because if you're in the desert, for example, and you're shouting, the wind is blowing the opposite direction. Your sound wave are being carried opposite to the direction you intend. Then the higher the temperature, of course, it also affects the speed of the sound. So loudness does not affect. Instead, your loudness now depends on the rest. If the temperature is favoring you, if it's not, if the material medium too is favoring you, like in a vacuum, nobody will hear your sound, no matter how loud you shout, because there are no air particles to carry the sound. That's why, like the way I'm talking now, though you're not in the room, it's being transmitted to you using electromagnetic waves or your radio waves. But if somebody is in this room with me, why they can hear me speak is that there's air. So as I'm speaking, the vibrations from my lips are being carried from the air towards the direction of that person. So if there's no air, no matter how loud, that's why you see astronauts. They are close to each other, but they will speak using what's it called? Their communication system, radio communication system. All right. Now, a convex mirror is used as a driving mirror because they have wide range of view. But what's the disadvantage? Of course, the fact the disadvantage used to be written on mirrors then. They will write that objects in the mirror are closer than they appear. True or false?
Yes, sir.
So what is the disadvantage? Whatever mirror you are, whatever image that looks as though it is far, it is actually close by. So that's the disadvantage. So the answer is clear, very very clear there. So the disadvantage is that the object appears as though it is far away, though it is what actually close to the driver. So the answer is option D. Then 78, very easy, right? Is it not? So what did they say we should look for? They said we should look for. It says the amount of heat released when 0.02 kilogram of water vapor condenses to water is what is dash. Now, first of all, what's going to happen? Condensation is the process by which what a vapor becomes a liquid or a liquid becomes a vapor. So that means there's latent heat. For those that are in SS1, let me explain what latent heat is. Latent heat is that hidden heat. For example, if I bring I said latent heat is the amount of heat that enables your substance to change state, and that heat is not being supplied by you. For example, if you bring out ice block from the fridge, you don't need to boil it, just leave it for some time. Automatically, that ice block will melt into water because there's a hidden heat in the environment. You don't. You, of course, you can make it faster by boiling the ice block, but naturally, just leaving it for some time leaving it outside can make it to do what? Can make it to become what? Can make it to become um, water. That means can make it to melt. There is also a temperature that naturally, have you heard of there's a particular stream, I think it is Ekiti State or so, that the water is perpetually cool. Have you seen those kind of temperature? There are also places like the Antarctic region whereby naturally the temperature there is freezing. So if you bring out water without putting it into ice block, just bring out water, that heat without being supplied by you will convert your water into what? Will convert your water into blood. Just like the same way here, since here is not really cold, it's warm. You bring out your ice block naturally to melt into water. So what happens is that first of all, the latent heat will first work, will first convert your vapor into what? Into what's it called? Into water. So that's the mass, the formula for latent heat is mass times the heat. And then after that, what's going to happen is that your water is now going to what? Your water is now going to gain heat to become your vapor rather is now going to gain heat to become what? Water. So what will I have there? Now the mass is the same. Okay, cancel out the mass. It's the same mass of water, assuming that there are no losses. It's the same amount of ice that will give me the same mass of water. Mass will not change. The latent heat of vaporization is what? Wait, am I on the right question? Okay, yes, yes, yes. They did not. They did not indicate in the question where they're supposed to. Anyway, the latent heat of specific latent heat of vaporization is 2.26 times 10 to the power of 6, but it will be indicated. I believe this must be an error. So this is going to give you 2.26 times 10 to the power of 6.
Mr. Chike, please, a second. Someone's hand has been up. Tamuno. I don't know what he or she wants to say. Please let
Okay.
him go ahead.
Oh, sorry. Please ask your question. You know I'm not on the app. I didn't see that. Sorry. So ask your question.
So please concerning our second class, this is going to be we're having on
The second class, you're having chemistry is going to hold.
I'm just waiting for the chemistry teacher to notify me when he's ready. That's why I haven't ended the class.
So the second class will hold. So once the teacher is available, you would start the second class. All right. All right. So you're welcome. So it's going to be equal to now what is specific heat capacity of water? Since this one is in, what's it going to be? For those of us that have done it now, SS3 is going to be what? 4,200. Then change in temperature is going to be vapor. It's gotten when you boil water, right? At the boiling point. So it's going to be, yeah, so it's going to be, what's going to be change in temperature? So from that vapor to 97, it's going to be 100 minus 97, which is 3. So I would have, okay, sorry, let me clean this up so it will be clearer. So what they actually ask us to look for, I thought they asked us to look for the latent heat of vaporization. What they actually ask us to look for is the total heat that is released. Okay, the amount of heat energy released. So first of all, the first amount of heat released is the one from the environment that helps to cool down the vapor into water. Plus, then the water will not gain that heat and then become what a liquid. So it's going to be first quantity is your latent heat, plus second quantity is your what? Your heat needed to convert that vapor into water. So it's going to be what's the mass? The mass is 0.02. You can actually factorize it. Let me just increase it a little bit so that I have more space to solve. So you can actually factorize out your mass here. Factorize out your mass. I'll have mass into latent heat of vaporization plus C times change in theta. So what is the mass? 0.02 kg. So 0.02 kg, 0.02 kg. indicated heat of vaporization is 2.26 times 10 to the power 6 plus specific heat capacity of water is 1,200 times. Now, since vapor is at 100 degrees and they want it to condense to 97 degrees, the change in temperature is going to be 100 minus 97, which is 3. So doing this now, and I have 0.02 into 2.26 times 10 to the power 6. 10 times, okay, then plus 4,200 times 3. So what does that give me? 2,000. What does that give me? Yes, class, what do we have?
So I got 222,720.
22,726,000. Okay.
2,272,600.
Okay, so that's 2 million. Yes, 2 million. I just typed that in. 272,600. None of them is within close. If I convert it to kilojoules by dividing by 1,000, what I have, I'm going to have 2272.6. So looking at it, the closest there to 2,000. So what's the closest there? Well, the answer is 2272.6 kilojoules. That's the correct answer.
So I
Yes.
have a question.
Yes,
This
please.
2,270, this 2,272,600, you not 90 by 0.02.
Okay, I think I did. Let me see.
You not.
Okay, I did not. Yes, I did not. So let's do that.
You because I'm 402.
Okay, thank you for that. I didn't notice we didn't do that. So it's going to be 45,452, which is option A. So thank you very much for that observation. Metric liquid. That means why don't we use water inside your thermometer to measure temperature? Why? Basically, why? What do you think is the answer among those options? It clings to glass, right? So that means, and if there are many, well, we just have to pick. The worst. We have to pick the one that totally disqualifies because yes, it clings to glass. That's one of the disadvantages. But at least some part of it is going to still move up. But as a thermometric substance, one of the characteristics of liquid in glass is uniform expansion. If you remember, there's a question on it. At 4 degrees, we have anomalous expansion of water. Water does not expand uniformly. It expands, then contracts, then expands again. So basically, do you understand what I mean? That yes, it's clinging to glass is actually a disadvantage, but it's some part of the water that will cling to glass. I think you should be able to see the top, what's it called, meniscus. You understand? Only that some part of it will be at the bottom of the glass. So it's not totally the characteristic that disqualifies it, but as a whole, water does not expand uniformly. So that's what disqualifies it as a thermometric substance. So the worst, just like they are all bad, but the worst of it is its inability to expand uniformly. So that's why. Question 8, it says, so that's B. Question 8, it says, what is the temperature? This SS1, 2, okay, I'll see here. What is the constant temperature at which water changes into gaseous state? What's it called? Somebody help me out. What's the constant temperature? Is it evaporation? Is it melt? Is it dew point? Is it boil? Boiling, right? Now, yes, you are correct. Now, evaporation was disqualified because it said constant. Evaporation does not have a constant temperature. In evaporation, water changes to gas, but it's not at a particular temperature. But boiling, like the boiling point of water is 100. If you keep boiling it, it will vaporize. So the answer is boiling point. Now, that other question I was talking about is here. I said water does not expand uniformly. At 4 degrees Celsius, you can see it is contracting, going downward. Then after 4 degrees, it starts going upward again. It's called the anomalous. That means it's not uniform. It's an abnormal way of expansion of a liquid. So basically, the answer is just straightforward. It's anomalous expansion of water. Question 82. Question 82. What's the answer? We'll just use the equation of motion. Let's not waste time. It's thrown horizontally. So in horizontal, gravity is not. Where am I? Question 82, yes. So we are told to get how far. So that means I'm looking for distance, right? I'm looking for distance. So first of all, what I need to do is to get the time, because since it's horizontal, we can use the equation of motion. I have the distance as 45 meters. I have the speed or velocity as 20 meters per second. So what can I do to get the time? What can I do to get the time? We'll use the equation of motion, right? So we'll consider it vertical motion, where you have S is equal to UT plus half AT squared.
So the answer is 60.
Okay, let's check that. Yes, the answer is 60. You're correct. Looking at what you just, yes, the answer is 60. But let's go on. Let's just prove it. Okay. So since for vertical motion, initially a body is at rest, so U is 0, so this becomes 0. So S is equal to half the acceleration into gravity t squared. So here is S is 45 equals to half times n times t squared, which now give me 45 is equal to 2 here is 5t squared. Dividing both sides by 5, you have t squared is equal to 9. Taking square root, you now have t is equal to plus or minus 3. But time cannot be negative, so time is 3. So to now get the how far from the base, that's horizontal distance, right? So we know that speed is equal to distance over time. So distance is going to be speed times time, which is, what is the speed? 20 meters per second times, what is the time we got? 3, which is 60 meters. Yes, you are correct. The answer is 60 meters. Do you understand? Hope I'm not too fast. If I was too fast, let me know.
Yes, sir.
Okay, so we get it, everybody. So question 83 is quite straightforward. They say calculate the maximum speed. So what's the formula for maximum speed? Normally, V is equal to R omega for circular motion. So I think we did this. Did you do this? Did we do it? So the speed is equal to R times omega. So for maximum speed, the angular speed will be A, the amplitude, the maximum displacement. So what's it going to be now? What did they give us? They gave us the spring constant. Now the spring constant is square root of K over M. These are another formula for getting the angular speed. So that means from here, now I have V is equal to R. Now that W is square root of K over M. So they told us to actually get its maximum speed. So let's do that together. It says calculate the maximum speed of the body. Okay, good. So it says a body of mass 0.5 kilogram is attached to a spring of force constant 200 Newton per meter. So if the amplitude is 0.1, that means I need to get the what? I need to get the amplitude. So the amplitude is 0.1. Calculate the what? The maximum speed. So let's get the maximum speed. Amplitude is 0.1. So I need to get the what is it called? Angular velocity. So let me write this formula again to reflect that. So we have that V is equal to R times omega. So at the amplitude, this is like circular motion. You can be whirling it at this point. But the maximum displacement you can get is the radius from the center to the radius. So that means since they said amplitude, that means radius becomes the amplitude. So V is equal to A times W. So they're giving us the amplitude as 0.01 or 0.1, sorry, about 0.1. So we need to get the angular velocity, which I said is equal to square root of K over M. So let's get it together. So this is going to be angular velocity is square root of, what is it? Spring constant, 200 over what is the mass? Mass is 0.5, which is half. 200 divided by half is 400. And square root of 400 is 20. So that means the angular velocity is 20. So putting it here, this is 20, this is 0.1. So maximum speed is 20 times 0.1. And that should give me 2 meters per second. Are we clear on that?
Yes, sir.
Are we sure? Are we sure?
Yes, sir.
Okay. Question 84. It says a block slides down a rough plane at 30 degrees Celsius. Sorry, not Celsius. But at 30 degrees angle, not Celsius, with an acceleration of g over 4. Find the coefficient of friction. So let's draw the inclined plane. So there's a block sliding down. What's the formula for the force moving it down? Mg sin theta. Right? Then frictional force will act in the opposite direction because friction opposes motion. So since it is sliding down, friction will act in the opposite direction. Right? So it's going to be frictional force in the opposite direction. My notes blocking. So which is going to be, this is the frictional force. So what did they say we should look for? They said we should find the coefficient of friction, which is mu. Now, all right. So coefficient of friction is F over R, of which the effective force is going to be mg sin theta minus mu times g cos theta. Do you understand me? Because now frictional force at this point,
Yes, sir.
frictional force at this point is mu times R, of which R is equal to what? Mg cos theta. Are you getting me? So the effective force will be mg sin theta, which is the force making it to slide down, minus the frictional force, which is mg cos theta. That's the effective force. And mu is equal to effective force over normal reaction. And what is normal reaction? It is what? Mg cos theta. So looking at this, I can factorize out m. I hope you get what I did. Do you get what I did?
Yes, sir.
All right. So I can factorize that m. I will now have g sin theta.
Hello, Mr. Chike. The chemistry teacher is ready and is in another link.
Okay, okay, no
Yes.
problem. Just
Please run the phone.
all right. So let me just leave this only